Welcome to the third video that I've done, or am doing, on electrolysis, and as you can see this one's on electrolysis calculations. Before we get cracking, it's important that we have a look at a few key definitions. It may seem a little bit unusual to refer to moles of electrons, but I'm going to explain a bit more about this during the video, and you will be told in papers that a mole of electrons is worth 96,500 coulombs of charge. So those of you who do physics will be fairly used to using coulombs, and the mole of electrons is often referred to as a Faraday. So if you see 1 Faraday, that effectively means 1 mole of electrons. This equation crops up in some of the more difficult calculations, and you see this in physics. Q stands for charge, and that is measured in coulombs. I stands for current, and that's measured in amps. And T stands for time, and that's measured in seconds. Now, doing these calculations, you also will need to be fairly au fait with moles calculations, and quite often we're converting between moles and mass, so we probably should just mention that moles is mass divided by RFM. So while you're doing some of the questions here, it's very, very important that you have a calculator with you so you can work through the calculations at the same time as me. It would be a good idea to have a periodic table in front of you, because that's going to be your only sort of pictorial memory aid in an exam, and also have that triangle, which hopefully you've used in lessons, in front of you for doing the calculations. So let's get started. Typical question, but starts off quite nice and straightforward. So we've got molten sodium chloride, and we're electrolysing it, producing, unsurprisingly, sodium and chlorine. It's not an aqueous solution, so we don't need to worry about any other ions. The only ions we have in there are sodium and chloride. So the question initially starts with asking us about moles of electrons. I'm going to change colour because I prefer red or blue. So the first question is, how many moles of electrons are required to produce 1 mole of sodium? And we're going to use this equation up here because this one has the sodium in it. And we use moles of electrons in exactly the same way that we use moles of other substances. So we look at the big number at the front of each particle. And as you can see with the sodium equation, the number all the way through is 1. So 1 mole of sodium ions react with 1 mole of electrons to make 1 mole of sodium liquid. The chloride equation, which we'll come on to in a moment, tells us that if you have 2 moles of chloride, that will form 1 mole of chlorine molecules and 2 moles of electrons. And it's important that we can manipulate and use these mole ratios. So if we're asked about 1 mole of sodium, well, 1 mole of sodium, okay, was produced, we said, by 1 mole of sodium ions and 1 mole of electrons. So the answer to this question is 1 mole of E-, which is also 1 Faraday. As I said at the start, moles of electrons were the same as Faradays. So, next question. How many moles of electrons are released when 1 mole of chlorine is produced? So, let's have a look. Well, the number there is what we're concerned about. And that number there, because nothing has been written, is 1. So, if 1 mole of chlorine was produced, we're just using the larger numbers in the equation. So if 1 mole of chlorine is made here, it's taken 2 moles of chloride and produced 2 moles of electrons. So the answer to that is 2 moles. Okay, and you can see here that I've used the classical chemistry abbreviation for mole by knocking off the E. Saves so much time. So 2 moles of electrons, which is the same as 2 Faradays. So, take this on a little bit, let's make it slightly trickier. How many moles of electrons would be required to produce 11.5 grams of sodium? So before, we were using moles of sodium, now we're using mass of sodium. So we have to convert the mass into moles. And hopefully you can remember the equation, or the triangle that I quite often use with my students. Okay, that moles is mass over molecular mass, or RFM. So let's convert 11.5 grams of sodium into moles. Moles equals 11.5, and here's where you need your periodic table, so you can have a look and see if the moles of, well, what the RFM of sodium is, or the atomic mass of sodium. It's the larger of the two numbers, which is 23. So moles of sodium, and it's important that I tell you or the examiner exactly what we're working out here. And if you do that on the calculator, it comes to 0.5. So, last time it was quite easy. We only had 1 sodium being produced, and it required 1 mole of electrons. So we can see it's a 1-to-1 ratio. But this time we only make half a mole of sodium. But as the ratio is 1-to-1, we therefore only need half a mole of electrons. So as it's a 1-to-1 ratio, moles of electrons is a half. And the final question, how many moles of electrons again are produced when 142 grams of chlorine is produced? So we're going to be using this equation down here, and already you can see that we've got a mass of chlorine. So what are we going to do to the chlorine? Well, we're going to need to convert it into moles, so moles of Cl2, and we'll use the triangle again, so moles equals mass divided by RFM. So we've got 142 divided by, well, it's Cl2, and if you look on your periodic table, the mass, or the RFM of Cl is 35.5, and as we've got 2 of them, 35.5 plus 35.5 should come to 71. 142 divided by 71 comes out as 2. So, as we make 2 moles of chlorine, how many moles of electrons do you think we make? Well, when we had 1 mole of chlorine, we made 2 moles of electrons. So, we have 2 moles of chlorine. We're going to have to double it. It's a 1-to-2 ratio. So, moles of electrons equals 4, which is of course 4 Faradays. Okay, next question. So, have a read through. We're electrolysing lead nitrate. We've got lead being deposited at the negative electrode, and oxygen gas being deposited at the positive electrode. And the question doesn't even refer to oxygen gas, but the oxygen gas would have come from the water in which the lead nitrate was dissolved in. Admittedly, it doesn't actually tell us it's a lead nitrate solution, so perhaps not the best question to use. Anyway, I'm going to carry on. Now, it says here we've got 0.05 Faradays. How many moles of lead would be formed? So, it does actually tell us here that a Faraday is the same as a mole of electron. So we've got moles of electrons is 0.05 Faradays. Okay, in fact I'm just actually going to rub out the Faraday because we don't need to write it in there. Let's look at our ratio. So if I had 2 electrons, that would make 1 lead. Let's say, for example, if I had 1 electron, that would therefore make half a lead. If I had 10 electrons, that would make 5 leads. It's a 2 to 1 ratio. So if I've got 0.05 moles of electrons, that means I have half the moles of lead produced. Moles of Pb equals 0.05 times a half, and that's 0.025. And the next question, this covers really just converting moles into mass. So from your answer to A, calculate the mass of lead formed. Well, again, you can see that we need to use our moles triangle. So you've got moles, mass over RFM. So as we've got the moles, hopefully you've got your periodic table in front of you, so you can look up the atomic mass of the lead. So you can see that mass equals 0.025 times by the atomic mass of lead. Can you find that on the periodic table? It should come out as 207, if I'm reading mine correctly. And if you type that into a calculator, you should come up with 5.175 grams. Hopefully that's reasonably clear. Something an examiner might put in at this point is give your answer to 2 decimal places. Very frequently students get this far and then just leave the answer as that. So clearly you only want 2 decimal places, so those are the 2 most important ones. So I would normally write this as, I'd give actually more decimal places originally, and then I'd say this rounds to 5.18 grams. Quite often I'd show the examiner that I'd actually considered his request or her request, so doing it to 2 decimal places.